Hello all, welcome to the day 78 of the daily case study series for CBSE Grade 12. The question goes like this. A cricket match is organized between the clubs A and B, for which a team from each club is chosen. Remaining players of Club A and Club B are respectively sitting on the lines represented by the equations. Equation 1 and Equation 2 is given in Cartesian form and to cheer the team of their own clubs. Question 1. Find the vector equation of the line on which players of club A can be seated. Now this line for club A is given in Cartesian form. Let's take down that equation. L1 is x minus 3 upon 1 is equal to y minus 2 upon 2 is equal to z plus 4 upon 2. The vector equation is written like this. R vector is equal to A vector plus lambda times B vector. So A is a position vector and B is a direction vector. Now from L1 we get A as 3i plus 2j minus 4k, and B vector is I plus 2j plus 2k. Therefore the R vector can be written as 3i plus 2j minus 4k plus lambda times I plus 2j plus 2k. This is a vector equation of the line on which the players of club A can be seated. Subdivision B. Write the direction cosines of the line on which players of club B are seated. So this is for club B. Let's take down the second equation, which is x minus 5 upon 3 is equal to y plus 2 upon 2 is equal to 0 upon 6. So here the direction ratios are 3, 2, 6, and the direction cosines L is equal to A upon square root of A square plus B square plus C square, where A, B and C are the direction ratios 3, 2 and 6. This is equal to 3 upon square root of 3 square plus 2 square plus 6 square, that is 3 upon root 49, which is 3 upon 7. Next one is m. M is b upon root a square plus b square plus c square. B is 2 and the denominator a square plus b square plus c square, and the root of it has been calculated already, which is equal to 7. Then n is equal to 6 upon root a square plus b square plus c square, which is equal to 6 upon 7. So these are the direction cosines for the line representing club B. Subdivision C. If the line on which the players of club A are seated is perpendicular to the line whose Cartesian equation is x minus 3 upon 3 equal to y minus 7 upon 4 equal to kz minus 7 upon 1, then find the value of k. For the line A, the direction ratios are 1, 2, 2. We get it from this line L1. And the second equation is given in Cartesian form, which is x minus 3 upon 3, y minus 7 upon 4, and kz minus 7 upon 1. Rewriting this equation in the standard form, we get the first two are same, and the last one is z minus 7 upon k by 1 upon k. The direction ratios of this line is 3, 4 and 1 by k. Since the two lines are perpendicular, a1 a2 plus b1 b2 plus c1 c2 becomes 0. 3 times 1 plus 4 times 2 plus 1 by k times 2 is 0. 3 plus 8 plus 2 by k is 0. 2 by k is minus 11. So k is minus 2 by 11. Subdivision D. Find the angle between the lines on which the players of club A and B are seated. To get the angle, we use this formula. Cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 divided by square root of A1 square plus B1 square plus C1 square into A2 square plus B2 square plus C2 square. Here A1, B1, C1 represents the direction ratios for the line A, and A2, B2, C2 represents the direction ratios for the line B. A1, B1, C1 is 1, comma 2, comma 2, which we take it from line 1, and A2, B2, C2 is equal to 3, comma 2, comma 6, which we take from the line 2. So cos theta is 1 times 3 plus 2 times 2 plus 2 times 6 upon root 1 square plus 2 square plus 2 square into 3 square plus 2 square plus 6 square. That is 3 plus 4 plus 12 upon root 9 into root 49, which is 19 upon 21. That is theta is equal to cos inverse of 19 upon 21. So this is the angle between the lines on which the players of club A and club B are seated. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.